Dear students, in this recording, I'm going to cover a math lesson for March 1st. Remember to log into the Nearpod self-paced link and join the Nearpod and work out the questions along with me. Some reminders. You had Unit 6 modules assigned to you to complete this week. The only graded item this week is the Math Progress Learning that is due tomorrow. If you need help on this math progress learning, make sure to watch my tutorial video. In this lesson, you will learn the concept of experimental and theoretical probabilities and make useful comparisons. I will also go over some assessment questions for probability. Here is the first question. The bar graph shows the results of rolling a number cube 300 times. What is the experimental probability of rolling an odd number? It is called an experimental probability because it is the result of doing an experiment like rolling a number cube 300 times. Therefore, they want to call it experimental probability. We want to know the chance of rolling an odd number out of the 300 total rolls. Out of the 300 total rolls, what was the chance of rolling an odd number? And let's see. Rolling an odd number, 40. When 1 is an odd number, chance of rolling a 1 is 48. 3 is another odd number, chance of rolling 3 is 50. And the third odd number is 5, chance of rolling a 5 is 49. Let's find the total chance of all odds will be 48 plus 50 plus 49. That gives me a total of 147. So I can say that the probability of rolling an odd number will be 147 out of 300. This can be reduced by 3. So let's go ahead and reduce it by 3. And when I reduce it by 3, I end up getting an answer that is 147 divided by 3 is 49. 300 divided by 3 is 100. And I cannot reduce it any further. So the chance of rolling an odd number will be 49 over 100. And something over 100 can also be called a percent, 49%. How does experimental probability compare with theoretical probability of rolling an odd number? Let's look at that. The numbers on a number cube are 1, 2, 3, 4, 5, and 6. Right? There are 6 numbers in all. How many are odds? Odd are 1, 3, and 5. And there are a total of 3 odd numbers. Right? The probability of rolling an odd number basically is 3 out of 6. Theoretically, the probability is 3 out of 6. Or you can say 1/2. As a percent, you can say 50% chance of rolling an odd number on a number cube. But when we did an experiment, the chance of rolling an odd number is 49%. They're so close to one another, 49% and 50%, because the experiment was conducted so many times. It was conducted 300 times. Let's look at this question. Use the bar graph to find the relative frequency of the event. Relative frequency also kind of tells you the chance, right? Or how frequent this thing happens. So number spun, if let's go ahead and find the total number of spuns. 1 was spun 8 times. 2 is spun 6 times. And 3 is spun 9 times. 4 is spun 11 times, and 5 is spun 9 times, and 6 is spun 7 times. Also, let's go ahead and find the total number of spuns. Total, we will add 8 plus 6. 8 plus 6 plus 9 plus 11 plus 9 plus 7. And that equals the total number of spuns that we have, which is, people go ahead and find it. I got a total of 50. There are a total of 50 spuns. The probability of spinning is 6, right? What is the probability of spinning is 6? It is 7 out of 50. Or the relative frequency is 7 out of 50. Spinning an even number, we will only consider even numbers. So 2, 4, and 6, right, are all even numbers, and the probability of rolling an even number will be, let's combine and see how many even numbers we have. Even are 2, that occurs 6 times, and 4, that occurs 11 times, and then 6, that occurs 7 times. Altogether, the evens occur 24 times. Let's see, make sure, yep. 6 plus 11, 17, 17 plus 7, 24. So if I'm thinking about the probability for evens, I'm going to say it happens 24 out of 50 times. That is the relative frequency or probability. Remember to reduce 24 over 50. They're both even numbers, and you can reduce them by 2. Half of 24, 12. Half of 50, 25. Use the bar graph to find experimental probability of the event. Spinning a number less than 3. A number less than 3 would be a number that is either 1 or 2. Right? So 8 plus 6. 8 plus 6 gives you 14 out of 50. A number less than 3 is the number 1 and number 2 only. And you can definitely simplify 14 over 50 and make it 7 over 25. Because they're even, and even numbers can always be halved. So not spinning a 1. There are 8 ones out of 50. So not spinning a 1 will be the remaining 42 numbers out of 50. And I can simplify that. Because both numbers at this time are even, so I will say 21 out of 50 is the probability of not spinning a 1. Let's look at question 5, not but 21 out of 25. So spinning a 1 or a 3, remember in probability the word or represents an addition operation. So I'm going to do question 5 over here. So the chance of spinning a 1 or a 3. 1 occurs 8 times and 3 occurs 9 times. And that is 17 total. So the chance of spinning a 1 or a 3 is 17 out of 50. Let's look at question 6. Question 6 says, what is the chance of spinning a 7? I will say 0% chance because there is no 7 on a numbered cube. Let's go ahead and move on. There are 105 lettered tiles in a board game. You choose tiles shown. Out of 105, you just chose 1, 2, 3, 4, 5, 6, 7. You chose 7 tiles out of 105. How many you chose these tiles? So how many of the 105 would you expect to be vowels? Let's see. There's 1, 2, 3 vowels out of 7. So out of 105, how many would you expect to be vowels? can create some equivalent fractions and solve the problem. From 7 to 105, we do it 15 times, right? 7 times 15. And then 3 times 15. That gives you 45. So out of 105 tiles, I can expect 45 tiles to have vowels. I will continue from here in part 2.